Over the past several weeks, our lab team has been working with the Dobot Magician robot arm. At the end of this period, we were tasked with programming the robot to be able to solve a spelling puzzle by determining which letters are the correct letters and placing them into the correct spaces in the puzzle. To accomplish this, the robot must be able to sort the letters by shape and by color, and must also be able to determine the correct location for each letter. To be able to program the Dobot correctly, we went through the labs progressively learning about different methods to help accomplish our final task. In our first lab task with the Dobot Magician system, we were able to learn the basics of movement, changing the end effectors, such as the suction cup or gripper claw, using the conveyor belt and infrared switch communication. To get the hang of working with the Dobot and its software, we coded the robot arm to move a block from one spot to another. This gave us the basics of Dobot movement and functions. We then swapped out the end effector from the suction cup to the gripper claw. This meant that we needed to change our Dobot flow to compensate for the difference in end effector, but we were able to modify it so that the gripper claw worked as intended. We then took the next step in understanding how multiple systems can work together by implementing the conveyor belt and infrared sensor to move these blocks around. As you can see in this video, the blocks start on the conveyor belt where they are moved down the line until the infrared sensor detects them. At this point, the conveyor belt stops and the Dobot arm moves over with the suction cup to pick up the block and drop it in the designated zone. Now that the block has been removed, the infrared sensor is unblocked, signaling the conveyor belt to move again, sending the blocks down the line once more. This cycle can continue indefinitely and will work with any number of colored blocks. Now that we understand the basics of the Dobot Magician, we were able to program flows such as this, where the Dobot will move these blocks around in a pattern continuously. This is just taking what was done in the very first task, where we just moved a single block to a single location and combining it multiple times and in a cycle. After completing this lab, we had a great understanding of the basics of Dobot movement. In our second Dobot lab, we incorporated the use of a camera to help the Dobot Magician determine the desired pieces to pick up. Using the camera, we can filter what the Dobot sees by color and shape. In this first task, we used the camera to be able to identify shapes from the background. In the second task, we used the ability to identify shapes with the camera to determine the centroid of each shape. We could then use these centroids to determine the distance between the two objects. After that, we calibrated the Dobot Magician to match the coordinate system from the camera. This allowed the Dobot Magician arm to be able to see its surroundings and tie coordinates to the objects it sees. Using this relationship, we were able to tell the robot to pick a certain color and to sort it out of the pile. Being able to sort like this using the Dobot's sight is imperative for the final task. In the third lab, we were tasked with working alongside another Dobot to either send or receive a colored block. In the final task, we will be required to work with another team and be able to perform both the sending and the receiving actions. So, we decided to be the sending team. This required us to pick up a block and drop it into the range of the other Dobot, where we would then send an electronic signal to the receiving Dobot, to which it would then pick up the block from the middle and drop it on their platform. This task is essential for being able to learn how to communicate between two Dobots. In the next task for this lab, we had to perform a match where we take a cutout of a piece and rotate it, so then it fits in the template. To perform this, we needed the Dobot to see the angle of the piece, then recognize how much it rotates the piece for it to match the angle of the template, where it will then fit once the angles are matched. This task is also very important for the final task because the letters will be sent at random angles. The receiving Dobot must be able to correctly rotate each letter so that it fits in the puzzle. Incorporating all the necessary procedures, we must develop two separate flows, one for sending the correct piece to the other Dobot, and one for receiving the correct piece and placing it in the correct space on the puzzle. For the sending flow, we wanted to accomplish the task of determining the correct piece from the pile, then sending the correct piece to the other Dobot. To successfully do this, the Dobot is first calibrated so that the coordinate systems for the Dobot arm and the camera can be translated. From here, the camera filters all colors out that are not the desired red color. After that, the remaining letters are put through a fast match that enables the Dobot to determine the correct letter to pick out. Once a letter is determined to be correct, the arm uses the suction cup to pick up the letter and move it to the drop zone. This cycle then repeats for every correct letter that the camera can find. On the receiving flow, it starts by picking up the letter from the middle drop zone, then places it in view of the camera. Now that the letter is in view, the flow then determines which correct letter it is by going through a series of branches and fast matches. Once the flow falls through for one of the correct letters, a shell module is used to help calculate how much the piece should be rotated to fit inside the designated slot in the puzzle. Once that is figured out, the Dobot arm simply picks up the piece and places it in the puzzle. Then, once the sending Dobot has another piece in the drop zone, the receiving Dobot then moves over to pick that piece up, and the cycle continues until all of the spots in the puzzle are filled. And here is the final demonstration using everything learned over the past few weeks in different lab activities. You can see that the Dobot successfully picks out the red D, O, and G letters and places them in the drop zone for the receiving Dobot to pick up. On the receiving end, you can see the Dobot picks up the letter from the drop zone, places it in the camera's view, waits a little bit for the flow to determine what letter it is, then places it in the correct slot. It'll then repeat this cycle until all the slots in the puzzle are filled. Thank you for watching our video and our showcase of what we have learned with the Dobot Magician robot arm.